in the session. So presenters, you're very welcome, and looking forward to actually having some discussions on what arises from your presentations. So Hadi, I'll hand over to you, and if you could actually load first presentation, that would be great.
Please do let me know if you can't hear the voice. Hopefully everything's gonna be all right.
Super, we'll do that.
The research today I'm going to talk about is research and the adaptive design strategy of smart house based on residential demand. With the development of Internet of Things technology, great changes have taken place in people's living environment and higher requirements are put forward for current living quality. The house can no longer be just a static shell that carries family activities. In the existing research, there is a lack of research on the adaptive integrated design of smart houses that focuses on the needs of family living. As you can see, this is the definition of smart house and residence adaptability in this article. So I hope to propose adaptive design strategies for smart houses through research and provide a reference for improving the quality of living. Based on the current social background, the research applies the methods of literature research, actual research, and product research to establish a correlation system among living space, living demand, and a smart home system. Then, through program design and practice, the study proposes the adaptive design strategy of smart houses from two aspects: space adaptive design and smart home scene setting. The viable design of the living space can help cope with the changes of the family's structure, and with the help of the smart home system, it can better meet the current living needs. This is a changing trend of living demand. These are the three elements of adaptive design of living space. Through research, the current smart home system can be divided into four categories. They are security system, smart home appliance and its control system, environmental control system, and health care system. The research simulates the residents' living behavior throughout the day and creates a smart life scenario. For example, the smart speaker wakes up the user on time in the morning and turns on the wake-up mode at the same time. A series of smart devices cooperate with people's 24-hour home life. The 2435 housing home was designed and completed in the context of the third China International Solar Decathlon competition in 2021, which aims to design and build a solar smart house that can meet the needs of users 24 hours a day and the living needs of households with a life cycle of more than 35 years. In response to the dynamic residential needs, the plan responds from three aspects: dynamically adapted function settings, flexible space design, and flexible and efficient structure selection. First of all, in terms of space organization, the plan selects a highly adaptable 9宫格 space prototype. In the design, the bedroom and the multifunctional room have the same scale and are arranged in mirror images, which can be flexibly changed and used according to the changes in the family population. With the help of flexible partition in the usually epidemic carbon room, the lifestyle in both the epidemic period and the general period is considered. This is the design of flexible partition. The living room adopts an open large space form and puts a movable box. Its movement defines the spatial effects of different feelings. At the same time, the toilet, shower room, the washstand are set up as independent basic units to meet different needs. The design uses a modular dual structure system. In terms of smart home control system, the scheme has designed photovoltaic power generation control system, HVAC control system, and a smart home control system. This is a full part of the photovoltaic power generation system. Through the design of the system, the house is put into use photovoltaic system to the maximum extent. The system automatically controls the electricity consumption of the house. In the HVAC control system, air and solar energy are used as heat sources to provide heat for the radiant floor heating system, which is economical and efficient, and at the same time improves the comfort to the human body. The plan also applies intelligently controlled air conditioning system and fresh air system. The solution is based on the relevant system and it creates smart life things such as smart sleep, smart access control, smart security, smart lighting, and so on. The research analyzes the realization path of the adaptive design of smart house. The design improves adaptability of living space from the three aspects of structure, space, and function setting. The application of the smart home control system ensures the safety of living and improves the convenience of life. The application of HVAC control system realizes environmental control centered on user comfort. The application of the photovoltaic power generation control system has realized the low carbon and energy-saving residential needs. In general, the integrated design and practice of the 2435 house provides a reference for the construction of smart home and the improvement of living quality. I hope you enjoy my speech and thank you for your listening.
Okay. Thank you for a very interesting overview of your research, Lingxi. I'm going to open up to the floor if anybody would like to raise a question. Lingxi is present with us, so if someone has a question, could you raise your hand? Okay. So if you give yourself access, Li Yongtu, give yourself access there to speak. You can pose a question for Lingxi. I hope I'm pronouncing the name.
How is the smart house in your project reflected in the application scenarios?
Lingxi, did you get that? Hello.
Okay. Hello.
Thank you.
Okay.
Yeah, we can hear you.
Okay. I can. The scheme has designed a photovoltaic power generation control system, HVAC control system, and a smart home control system. And the photovoltaic power generation system of the house realizes the green production capacity and the energy independence of the house through the intelligent use of renewable energy, solar energy. And the plan uses a floor radiant heat system and an air conditioning system with independent temperature and humidity control. And the air conditioning system improves the comfort of the indoor environment.
Okay.
By accurately controlling the indoor temperature and the humidity parameter, and the operating status and the indoor parameters of the air conditioner can be connected to our smartphone via a wireless network, we can detect the condition of the indoor environment in real time and easily control the air conditioner as required. At the same time, the fresh air system through air treatment on the basis of ensure the freshness of indoor air. It also reduces the load of the system through waste heat recovery to achieve the purpose of saving energy. And finally, through the thin linkage of the smart home system, the siting and conversion of different life scenes are realized to better meet the living needs. And thank you.
Okay, thank you. Lee, does that answer your question?
Yes.
Okay, great. El Hag, you have your hand up. Would you like to pose a question for Ling Shi?
Hello, Ling Chi. Thank you very much for a very interesting presentation. You mentioned that is part of solar decathlon. Can you explain to us how the specs and regulations and requirements of solar decathlon got impact on your design and construction, and also how do you assess your house, the design and the construction stages of it with other houses also involved in solar decathlon? Thank you.
Over to you, Ling Shi.
Okay. And the main principle of solar power photovoltaic power generation system is to use the photovoltaic effort of solar cell semiconductor materials and to directly convert solar radiation energy into electrical energy. And the photovoltaic power generation system is mainly composed of solar cell component, storage batteries, charge and discharge controllers, and inverter. And based on the function of the above component, the operation mode of the solar photovoltaic power generation energy system is the electricity generated by the photovoltaic array is either charged by the charge and discharge the controller the battery of or directly supplied to the DC load. Then there is no sunlight or insufficient sunlight. The battery will supply power to the DC load under the control of the charge and discharge controller. For AC load, the inverter is needed to convert DC to AC.
Okay. Okay, thank you for that. El Hag, does that answer your questions? I don't think it answers the second question for you, does it?
Yeah, thank you. Yeah, that's the first part. I'm happy with that. The second part of the question, Ling Shi, is the comparisons between your house and the other houses involved in solar decathlon. Do you have any views about the other houses competing in solar decathlon?
Okay. Because in the current research, most of the research on the smart house focus on the intelligent control of building energy consumption, and there lacks integrated design that pay attention to the comfort of individual residents in terms of residential adaptability, whether it is flexibility, variability or flexible design. Most of them use traditional design method to improve space flexibility. And there are few studies on integrated design with smart home system. And the design is based on the solar decathlon competition as a platform, and through the design of a variable space and a residential intelligent system to meet the living needs of a family within 24 hours a day, and the living needs of the 35 years family's full life cycle. At the same time, the design aims to provide a reference for constructing smart house and improving the quality of living.
Okay, thanks, Ling Hee. I'm going to move to our second presentation. Thank you, Ling Shi, for answering the questions and for your presentation. The second presentation, Hadi, if you would actually load it up, that's great. It's from Mohammed Salama and Sharon Vokar. It's smart cities in developing countries with an emphasis on GCC countries and its impact on expatriates amidst the COVID-19 pandemic, and it's a systematic literature review. So, and I see Sharon is with us, so maybe you'll have some questions for Sharon after the presentations. Okay, Hadi, off we go. Is there a problem?
My apologies. Is the sound okay?
No, there's no sound for me.
Okay.
Kuwait study on smart cities with an emphasis on GCC countries and its impact on expatriates amidst the COVID-19 pandemic. A systematic literature review. My co-author is Dr. Mohammed Salama. The Gulf Cooperation
I think the sound has gone again, Hadi.
I can't hear either.
No. Hadi, can you maybe unmute yourself, Hadi? Maybe it's coming through your microphone. Hadi, have you had a chance to look at it?
My apologies. I'll just do it again then.
If that persists, I can share my screen. Hadi.
19 pandemic. However, research has been slow in investigating the impact of the smart cities initiatives on the expatriates within GCC. Our research paper addresses several questions related to challenges, the drivers, and the effects of COVID-19 on the expatriates with respect to smart cities initiatives within the GCC countries.
Missed. This has jumped slides.
At the start of our research, we searched for smart cities. And as we expected, there was plenty of literature. even when we looked for smart cities within GCC countries, we found a good number of papers. However, when we looked at research considering expatriates in smart cities in GCC, we couldn't find any papers. And that gave us the motive to start looking into this as a gap. Therefore, we started our research by looking at smart cities initiatives within a wider context, as well as within the GCC countries, to identify constructs which we then analyzed and evaluated, linking it to the expatriate population and the COVID-19 situation. Hence, the systematic literature review followed a methodical framework, beginning with a search of relevant literature across numerous databases, web engines, and subscriptions. These were compiled using the PRISM flow diagram. The constructs identified from a wider relevant literature with the main criteria of smart cities initiatives were mapped and analyzed methodically with respect to the context of GCC countries. We will now discuss the three main identified constructs of challenges, drivers, and the impact of COVID-19 within the GCC. On investigating challenges faced in the development of smart city initiatives within the GCC, we mapped the relevant points under themes such as the governance, ecological factors, societal and technological challenges. Further, each of these themes was subdivided into factors. The main themes for the construct drivers with respect to smart city initiatives in GCC were economic growth, a potential for renewable energy, and diminishing reserves. The impact of COVID-19 within GCC was a significant construct. This study covered the effects of COVID-19 on the economy and the subsequent effects on the expatriate population, as well as the measures to curb the spread of this pandemic. This systematic literature review draws attention to the fact that research on smart cities initiatives within the GCC countries are fragmented in their approach and lack a holistic viewpoint of the entire GCC region. The study draws attention to the significant gap in research, which is the impact of smart cities initiatives on expatriates within the GCC countries. It is evident from the constructs that expatriates played a significant role in the economy and development of GCC countries. The smart city initiatives have a considerable impact on the expatriates. The systematic literature review that we have presented aims to justify the gaps and provide a roadmap for research that is required to address this gap. There is a need to research the impact of smart city initiatives on expatriates in GCC countries, as well as to identify these with respect to pandemics such as COVID-19 situations. I thank you for your time and patience.
Okay, thank you, Sharon. Have we any comments that people would like to make? It was a very interesting topic, and I think it's very interesting that you've narrowed it down to looking at the expatriates element of it. I suppose my question is what evidence in terms of numbers of expatriates in the region did you identify?
Can I answer the question?
Yeah, absolutely, Sharon. Yeah, it's over to you.
I'm so sorry that you missed out on the first, the introduction to the.
I really apologize for that. Apologies.
Yeah, that would have given a kind of a overview of what the GCC countries are. But
Okay.
yes, can you please repeat your question again?
So just, I suppose, yeah, we missed out on the overview, and I suppose I'm just wondering in terms of, what are the communities of expats, and what are, what sort of numbers are we talking about, and did your literature review uncover that information or that knowledge?
The expatriate population within the GCC countries is very high. In the UAE itself, it is about 92%. It's much lower in Oman and in Saudi Arabia. It's not much lower. I would say it ranges from around 75% to about 92%. Highest, of course, in the UAE. So we're looking at a large amount, a large population of mobile people, expatriate population, which is a very, very vulnerable human capital pool for MNCs in these countries, and they're responsible for having built this region. And we were looking at research, how the smart city initiatives impact this population, especially in the current situation of the COVID pandemic. So
Okay.
it is yes, so it is a systematic literature just covering what has been written on, we're looking at the literature on this topic. So we can decide on a direction for empirical research further.
Okay, super. That's really, really helpful. Thank you, Sharon. Al Hag, you have a question?
Yeah, thank you. Thank you, Sharon, for a timely topic here in GCC. I assume that there are quite big similarities between the 6 countries, GCC countries, on this issue, smart cities and the impact on expatriate. But do you think that there will be also some differences, and what kind of differences you expect, and to what level when we talk about these 6 different countries? Thank you. And also compare that with other countries, because here, as you just said, there are a high percentage of the population expats, but if you compare it to other countries in other regions, the situation will be a bit different. Thank you.
Yes, I agree with you. The situation would be very different compared to other regions. That's why we limited our context to the GCC countries. Of course, another country which has very high amount of expatriates, we realized, was Singapore. But of course, just to there's a plethora of information and literature written on expatriates, but we found very limited. We found this gap in the literature wherein within the GCC countries there is a very little, almost nothing, actually nothing written connecting smart city initiatives to the expatriate population. And I think, I'm sure that especially during the COVID-19 pandemic, smart city initiatives had a very vital role to play in mobilizing and, helping out this large expatriate population, because COVID has affected the expatriate population, especially in the GCC, very significantly. So I think there is need for research to look into, I would say, how this, there is need for more in-depth study and data on the provisions of smart city initiatives for topics like for failure management, or in situations where such as this COVID pandemic, or it would help future perspectives on how to handle expatriate populations using smart city initiatives.
Yeah, thank you, Sharon.
So we kind of just evaluating a gap in the research on smart cities within the GCCs and its impact on the expatriate population, especially during situations such as COVID-19. COVID-19. And looking at the literature from different perspectives, such as the challenges, the drivers, the the effect that it had. Of course, there is no empirical research available on this. So this systematic literature review just kind of gives a direction that work needs to be done to to fill up these gaps.
Thank you, Sharon. Lloyd, I think you're on mute. If you could.
Thank you. Absolutely. Al Qawadri, would you like to raise a question? Thank you.
Hello, just one question to Sharon. Why do you think there would be a difference between the impact of such initiative differently on experts? What are the aspects that you think that it will impact them differently than the local community? Thank you.
This is a very important question, and I'm happy to answer it. You see, the expatriates are a very vulnerable human resource out here, and when they lose their jobs because of the pandemic and because of the the after effects of the pandemic, a lot of them are laborers living far away from their family. They are in isolation, so handling them, smart city initiatives, it's very different from locals, because locals are in their own country. They are protected by the government, and they have you would say they're in their own land. While expatriates, when they lose their job, they have to be sent back to their home countries. So and that would be in large numbers, because we're talking about like almost 92% in UAE. We're talking about 70% of the population. So that does create a lot of especially in the GCC countries. That is a lot. That is a significant amount of mobilization and planning required to take care of this population, which no longer has a job, or it would be the same as as for the people who are locals in that country, because they don't need to be sent back home, or they don't, even if they lose their jobs, they still have a certain sense of security.
Okay, thanks, Sharon. Okay, I think we'll draw your presentation to a close. Thank you, Sharon, for your contribution. Apologies for the technical issue. It's a really interesting topic, and I'm sure we'll actually get access to your research as it unfolds. So thank you for that.
Yes,
Our next...
plenty of details actually when in the paper. This is very short time for me to cover up the details, but do read the paper. I'm sure you'd find it interesting.
Great, thank you. Our next presentation is from Ahmed Fadil Dulami. It's Creating Smart Cities. It's a case study of the Energy Hub for Effective Energy Management. Okay, thanks, Hadi. I think we've no sound, Hadi, again.
One of the critical challenges. Hi everyone, I'm Ahmed Dulaimi. I'm Facilities Manager working with Innova by Vulia. Today I am presenting my paper on promoting Energy Hub as an innovative solution towards creation of smart cities. One of the critical challenges facing our humanity these days is the scarcity of energy. These challenges appear in different fields: in energy supply, exchange, and consumption. The energy scarcity is due to population expansion, growing demand for energy, natural resources shortages, global warming, and other environmental concerns. Furthermore, scarcity of energy requires growth of renewable energies, improve energy efficiency. It is considered a top priority for all governments and organizations to resolve this problem. Nowadays, the development of new technologies and IoT lead to realize the benefit of having integrated energy management system that combine all types of energy consumption. This brings attention to create sustainable smart cities. Many countries are now combining customized services and businesses within energy infrastructure and urban environment to build sustainable smart energy city. To build such city required suitable tool to manage all these components, all type of energy consumption. And Energy Hub is a promising solution to integrate all energy management systems. Energy Hub can provide benefits to all citizens, such as convenience, safety, and cost saving, and also reducing carbon footprint. Smart Energy Hub uses advanced applications, communications, digital information, and automated monitoring technologies to optimize and improve the operation of energy network. Energy Hub can be divided in two types, macro hub and micro hub. It depends on the control and patterns of consumption or the objective of consumers. A smart city is a city that uses several sorts of data, using several sorts of sensors to capture electronic data and provide information that is then used to manage assets and resources efficiently. These data is about citizens, devices, assets. It's processed and analyzed to enable traffic and transportation systems, power plants, water supply network, waste management, information system, schools, libraries, hospitals, and other community services. All these to be monitored and managed on one unit. One of the pioneers in developing Energy Hub is Innova by Veolia. They were able to develop an Energy Hub called Hub Grade 4 that managed energy consumption and material flow for their clients. Hub Grade 4 provide an innovative approach to successfully implement energy efficiency improvement using artificial intelligence and real-time data. It depends on connected sensors and products. Innova by Veolia is a regional leader in integrated energy and facilities management. Hub Grade 4 incorporate all collected data from energy management systems, waste management systems, platforms, water supply, quality monitoring systems, control system, building management systems, SCADA, carbon footprint calculator, indoor air quality, financial analysis and benchmarking. All these are included and is part of capability of Hub Grade 4. In our case study, in Hub Grade 4, the sustainable report for the last 3 years for the projects and clients under and managed by Hub Grade 4, it shows saving around 253 billion kilowatt of electricity and 3 million cubic meter and around 138 million dirham saving. As a summary of this study, the case study reveals that the impact of increased population on Earth requires a huge effort to customize consumption of natural resources The optimal use of these resources requires a centralized monitoring system and integrated energy management that can optimize and reuse energy consumption and save the Earth resources. And introducing the energy hub as a concept provides a powerful tool to manage energy flow and energy consumption in real time using new technologies and IoT. And since this energy hub has the ability to integrate several services for different types of facilities, an energy hub is an excellent solution to optimize energy consumption and save Earth resources, leading to integrated energy management system. And as a future plans, this requires an intervention of government to play a significant role to form new policies, new technology, new regulations to incentivize and promote sustainable smart cities and enforce the construction of smart energy hubs as a part of the infrastructure of the city, and encourage building owners to adopt micro hubs as a part of the construction model for their properties. I think I reached to the end. Thank you for watching this presentation. I hope that you like it. Thank you.
Thank you, Ahmed. A really interesting topic, the whole integration of energy hubs. And I think, you know, it's certainly an area that's going to impact on us as we move into the future. I'd like to open the floor to any questions, and we can just take maybe one question given we're moving on in time.
Yes, thank you very much for the presentation. I'm sorry, I have tried to, can I ask the question? Because I tried to raise the hand, but I just find it.
Yeah, okay, go ahead.
Okay, I just have a question regarding the sustainability report that has been presented. There's a part in the presentation where the study has only applied on premium and green buildings. So I just would like to know what are the impacts, like which one was performing better in this case study. Did really the certified buildings differ from the the other buildings? Could it be possible just to highlight on that?
Ahmed?
Yes, actually, it was one of the initiatives from our side, from our company, is to certify the buildings under the services under the company. And we certified hotels for Majd al-Futain, okay? And all of them, they were LEED certified, and it helped in energy saving. And this report, as you see, it will give you real-time achievement on how the building is sustainable. Okay, if you are not using such report, you need to stay till the end of the year and make so many studies till you understand how sustainable your building. But one click, you can find your building. Is it making saving? Is it sustainable? Is all the energy measures are working fine?
Okay, thanks, Ahmed.
Thank you.
Are you satisfied with that, Ahmed? Other Ahmed? Are you satisfied with that?
Yes, actually, I was hoping to look again on the slide and get it further. So maybe I will get in touch later on with Mr. Dulaimi, so we can discuss it further. Thank you very much. Yeah.
Thank you. Welcome. That's a really good point in terms of actually, you know, for people to feel free to contact each other and share knowledge and seek information. So thank you for your presentation, Ahmed. It was really interesting, and certainly I'll be interested to inquire further around these energy hubs, because I certainly think they're going to make a very, very positive contribution to cities.
We can provide a site visit to the energy hub if it will be planned by the CIB.
Excellent. Thank you for putting that forward. We'll pass that on. Okay, thank you for that. And we're moving on to paper number 4. So it's Abraham Karan and fellow researchers. And the paper is entitled Optimal Collaborative Energy Models Among Vehicle-to-Home and Solar Systems. So over to you, Hadi. Thank you.
Hello everyone, and thank you for joining me on the presentation for the study on optimal energy model among vehicle-to-home and solar system. My name is Abraham Karan. I'm an associate professor of construction management in the Department of Engineering Technology at Sam Houston State University, and our institution is in Texas in the US. And on this study, a few other people helped me to finish this study, and you can see their names on here. I would like to also thank them for their contribution. Okay, so folks, let me start with why we decided to do a study on electric vehicle in particular, and how the vehicle-to-home system can help us to fight the climate change. First of all, let me take a look at that one from the economic perspective, because we believe we're gonna see more and more electric vehicle, and I would say this one, replacing traditional car engines with EVs would be a very, very effective strategy to address climate change. So the graph here basically shows the cost of commuting or driving in the US. A comparison between electricity or EV cars that you can see they are relatively around $1.50 per equivalent of a gallon, and you can compare that one with other gasoline based. Pretty much all of them are higher, very close to $4, and of course if you use CNG or gas based, of course it would be cheaper, but it's still electric vehicles are very, very efficient in terms of the cost of transportation. And I can share with you a very simple calculation on here. I'm driving a Chevy Cruze. This is gonna be, the fuel efficiency of this car is around 30 miles per gallon. If we say that on the fuel price is around $3, the time that actually I'm recording this video is around that much. So basically I'm paying around $6 for driving 60 miles or 100 kilometers. Let's compare that one with what pretty much the same price car, but an EV. I would like to pick this Nissan Leaf. The efficiency of that one is 0.3 kilowatt hour per mile, and the mile that I'm paying for my electricity is around 12 cents per 1 kilowatt. So all this together, it's gonna, if I would drive an EV, it would cost me only $2.16 for that 100 kilometer or 60 miles. As you can see, it's gonna be almost less than half for me to the cost of transportation. So especially because of the economic aspect of the EV and electric vehicles in general, we expect to see a boom for the usage of this one. So, and on the other side, all EVs are having a battery, but we don't drive them all the time. Therefore, we can use the energy stored into the vehicles, and when we need that one, pretty much send it back to the grid. So that's what we call vehicle to home. This is a concept that enables EV batteries to associate with homes. Any vehicle that can be connected to an electric plug can be used for this technology. And again, the point of this one is to better transfer and distribute the electricity between our home and our vehicle. Let me again, our expectation is to see more and more electric vehicles, and which ultimately, of course, increase the demand for electric utilities, but also it gives us an opportunity to use them. On the other side, on average, residential house in the US would need around 24 kilowatt hour in a day. And when you look at the capacity of the batteries, which is 45 kilowatt hour, basically it says that one, if I run out of any electricity, but I have a fully charged EV, I can plug that in and use the energy in the stored in the battery of the EV for almost 2 days. Not to mention, of course, it's possible, of course, to save some electricity, especially in power outages, situations like this one, and of course take more of the time that you have. So that's the whole point, that okay, this is a good opportunity. Let's see if we can use that capacity of EVs, how much we make profit of this one, especially if we put everything as in dollar amount or the money. The comparison would be much easier. Okay, so we made an energy model regarding to that part. So to basically see what would be the best way to distribute the energy. First of all, if we generate some energy from our solar system, would it be better to store that one in our car or send it to the grid or use that one in the home? Not to mention, there are situations that would also impact our decision. First of all, your electric vehicle should be available at home. Otherwise, there's no way for you to store the electricity in your car. Not to mention that one, if the demand of your house is lower than the amount that you're gonna produce, there's of course there's no battery installed because you don't have your car in your garage. Therefore, the electricity will be back to the grid. So with all those situations, we made this model, ran some simulation based on the cases in Houston to find out what would be pretty much the optimal situations regarding to that distribution. Okay, so the chart that you see on the top basically shows how much electricity we can produce for that case study. We did that one for all months based on, again, a house in Houston, Texas. And of course, we get plenty of sunlight. And you can see that one, the peak time that we are getting solar would be around the noon, okay? And on the other side, that would be the energy consumption for a house. Again, during the day. And of course, when we get to the summer, we expect very hot summers, of course, in Texas, like in August. Those are the months that energy consumption would go way up, especially because of air conditioning use. And of course, in March, in spring, there's not much usage on here because the temperature is very comfortable. No need to put AC on or even a heater or furnace. Overall, the chart on the left, on the top right, would tell you about the consumption. On the other hand, on the bottom, you see all the traffic during the weekdays and the weekends. That would tell us where we can use, actually when we are using our EV, when it is parked in our garage, to basically charge this one. Having said this one, we came to some conclusion. For example, that the best thing to do is to make sure our EV is charged during the peak times. Okay, in some months we need more power. In some other months, we are in not a good situation. But overall, the demand for the house also plays a major role. I'm trying to finish this one in 8 minutes, but I'm hoping you can review the paper for more details.
Great, thank you, Abraham, and I'm glad that you've joined us here. Has anyone any questions? It's a really interesting project, and I liked the way at the start you drew the comparison in terms of vehicle use, in terms of traditional types of vehicles versus EV vehicles. Anyone like to raise a question for Abraham? People are conscious. It's coming up to lunchtime. Oh, Chris, you have a question?
Yeah, no, I thought that was a real useful presentation, Abrahams. I'm interested. So you really just offered a comparison to the heating and conditioning cycles. I'm wondering whether through the monitoring that you've done, or whether through other projects you've got some insight in how you might sort of optimize the use and develop it into a sort of a more smart system where you can achieve greater savings and improve the conditioning of the space as well.
Imran, would you like to answer Chris's question? You'd like to unmute yourself there?
Maybe he's lost connection, Lloyd. But if you can, he can probably come back another time. Okay,
thanks, Chris, for raising the question, and it's on the record. So we'll see. Does Ibrahim can he have at a later point an opportunity to address that question?
Thank you.
So just now moving to our final paper, and the paper is entitled "Net Positive Water Systems for Schools in Drought-Stricken Areas." And it's the paper is prepared by Jeremy Gibbard. So over to Hadi. Will you load the presentation?
Hello, my name is Jeremy Gibbard, and I'm going to be presenting on net positive water systems for schools in drought-stricken areas. I'm going to cover a little bit on the context, rainwater harvesting systems, a school site and climate, patterns of water use at a school, and whether rainwater harvesting systems can meet those water needs. Look at the financial feasibility of rainwater harvesting systems, and then finish off with some conclusions and recommendations. First of all, when we look at water scarcity, it's important to distinguish between economic water scarcity, which is where access to water is limited by human, institutional, or financial capital, even though the water might actually be available, and physical water scarcity, where countries reach a point where there is insufficient water. And what we find, as shown in that UNEP map, is that many African countries actually have both, or a mixture of these different types of scarcity. And in the case of South Africa, we have a situation where many schools experience water shortages, and the supplies are increasingly unreliable. The cost of water goes up as municipalities try and restrict consumption, and this sometimes results in schools having to close. And as you can imagine, there's a huge negative impact as learners don't go to school, and there's huge disruption in terms of curriculum. So one option is to look at rainwater harvesting, but there's very little research on this. So this particular study looks at patterns of water use in schools. Can they be met from rainwater harvesting systems? And then what's the financial feasibility of that? And it looks at a school in the Eastern Cape of South Africa, and it's a rural farming area that's experienced very high levels of water shortages really for the last 5 to 7 years. And you can see here, that's the school itself, very long buildings, corrugated tin roofs, that's the site, that's the facade of the buildings. And you can see here, there should be rain usually throughout the year. There's rain even in the dry season. So the first thing we did was to look at water use at schools using conventional equipment, and what we did was really look at consumption in terms of toilets, also in terms of things like drinking water, cleaning water. And basically we came to a figure of about 134,000 litres in terms of monthly usage. If you fit much more efficient fittings, so low water use toilets, aerators on taps, and you basically run the school much more efficiently, it's quite feasible to get that down to about half, so to about 75,000 litres per month. And when we run the modeling for the higher levels of water consumption, you can see there's a distinct issue around June, July, August, where there's insufficient rainwater to meet the needs of the school. So this is the rainfall, the roof area, the runoff factor, the amount of water harvested, the amount of water used, and you can see during those months there's a negative amount. So the building wouldn't be sufficient. There wouldn't be sufficient water on site to meet all of the needs at the school. If we take the more efficient fittings and the more efficient usage, we have a situation here where throughout the year you can see there's surplus. So actually, in this particular case, it's net positive. Effectively, this water could be exported to a neighbor or used, for instance, in terms of gardens. So moving on to the financial feasibility, the fortunate thing here is there's very large roof areas, so the cost really is linked to tanks, bases, plumbing, some filtration for drinking water. You get a capital cost of about 300,000 Rand. Rand is about 20 Rand to the pound if you're using British pounds. And we can do a very simple calculation to look at savings per year, and that gives you a payback period of about 21 years. So not particularly good in terms of payback period. But what's important here is to understand that schools using this system would avoid school closures and disruption, and that has obviously a major beneficial impact. So to finish off on some conclusions, the first thing is to understand that it's very important to have an efficient system at schools. The inefficient system couldn't be serviced just using rainwater harvesting, whereas when you took it down to about 18 litres per person, you could basically have an off-grid system. The third thing is to see that payback periods, if there's a reliable local supply, municipal supply is about 20 years. So not a particularly strong payback period. However, what's important here is to understand, obviously, that emergency tariffs double, triple, quadruple the tariffs. So very quickly, if you apply that to the school, that payback period drops radically to half, to 10 years or even 5 years. But much more important is the cost and disruption associated with closures and education disruption. And that's something that's very important. So what this study shows, which is very interesting, is it shows that it actually is possible to have a off-grid system that meets the water needs of a school. And really the last thing is to have a simple set of rules of thumb for different climates, as you can see at the bottom there, so that you could do calculations and feasibilities very quickly. Thank you very much. I don't know if there are any questions.
Okay, thank you very much, Jeremy, for a really interesting case study. and certainly a case study that can actually contribute to our knowledge and understanding of using net positive water systems for schools and the like, and to come at it not just from the financial spectrum, but also from actually, you know, what are the knock-on effects of actually implementing a system like that in terms of, you know, keeping the school open during periods of drought, etc. So thank you for sharing that study with us. I'd like to open to the floor. Elhag, you'd like to raise a question? I know we've slightly run over time, but I think we open up to questions and have a few questions to bring this session to a close. Elhag, over to you.
Thank you. I would like to know your views, Jeremy, on how you can fund such water harvesting for schools in different regions in South Africa suffering from this problem, given that you said that the financial visibility and viability is not that great for private investors if it is 20 years payback period. But do you expect the government will have this kind of funding, or do you think that it could be something like PFI, PPP type of initiatives to support that with the help of the government? Thank you.
Thanks, Elhag. I think that's a very good question. The answer depends on whether it's a new school or an existing school. I think with new schools, it must just be priced in. And I think, you know, the budgets as a percentage of the capital budget, in many climates, this could be done fairly easily and it wouldn't be a big increase on the capital, just because the tanks aren't that big and you've already got the roofs in place. So I think the policy must be here that if you're doing a new school in a drought-stricken area, particularly if it's in a rural area where you may not even bother with a water connection to mains, it can make a lot of economic sense, and the government must just pay for it, or if it's done privately, it just must be included in the capital. Where it's a retrofit, I think the argument for putting it in place, because it's so disruptive, you know, you can imagine generations of school children missing out on proper education, has such a negative impact that I think you have to look at government subsidizing it, local farmers, local business, parents, the municipality, because the negative impacts are so huge. You know, you have got crime, you've got unemployment, etc. And I think, you know, that's where the financial arguments are very interesting, because if someone could quantify that, it would be very easy to defend this, you know, having a net positive water system at many schools.
Okay, thanks, Jeremy. Really, really interesting conversation.
Thank you very much, Jeremy.
Thanks, Elhag. Ali, would you like to raise a question?
Yeah, thank you, Lloyd. So it's not a question, it's actually a comment that all of us, we must go back to the opening session for keynote speakers number 3 and 4, Dr. Ali Al-Azdawi and Professor Ghassan Awad. So we have to join the day 1 opening session again after the break. So just wanted to point that out. Thank you.
Thank you very much, Ali. I've actually had it on my list of notes to do, so thank you for actually giving people direction. I'd like to bring the session to a close and thank everyone for their contribution, both presenters and people who actually asked questions and engaged. And yes, absolutely, a round of applause for everybody. I'd particularly like to thank Ling Shi, Sharon, Ahmed, Abraham, and Jeremy. There are some really interesting projects shared, and providing us with the kind of contextual knowledge and research outputs from the research, and I'm looking forward to reading the papers and actually getting some in-depth knowledge from what you've shared. So a really engaging track 1 session, and thank you all for your contributions. And as Ali said, we need to go back to the general track at 2 p.m. And join the keynote speakers for this afternoon, and apologies for running 11 minutes over, but I think it was actually worth it for the engagement that we had in terms of the questions raised. So well done everybody, and we'll see you at 2 o'clock.